around in the country, and some technologies in and around Vijayawada itself is going. And where AP government has already employed with our suggestion and then trying to move forward in that. So what I will try to do is to, before I go to the technologies, the topic is sustainability. We talked briefly about sustainability, the construction aspect, how sustainable it is, what are the materials going into that, manufacturing elements that are going into how sustainable they are, right? And there are, after briefly going through that, then I will take you into the emerging construction technologies. At the end of it, I shall again review what are these technologies, how far they are sustainable, cost-wise, heat-wise, are they comfort enough, are they durable enough, those are the aspects that I will come into. Right, I'm giving 30 minutes time. I'll try to wrap up quickly, giving as much information as possible. Right, sustainability is a process, right? And it broadly is three components of sustainability will be coming up. One is environment, economy, and society. So to meet this goal, sustainable development must provide that these three components remain healthy and balanced. What we are talking about is environment, economy, and society. Right? So societal aspect is also there into that. Economy is one of the aspects, right? And then in order that we need to remain healthy, in the planet of Earth, both for the present living and for the future. Nowadays much talk is going around about sustainability, right? There are some of the issues that briefly we will touch upon, right? So then what is happening at the moment is the environment is called the most important component out of all the three whatever I have listed there, right? The environment, economy, and the society, right? And an engineer or architect uses sustainability to mean having no net negative impact on the environment. No net negative impact on the environment. This is what we are trying to look at. It is absolutely impossible to say that no net negative impact, but how far less is the criteria? That we will just repeat here. Right. Thus, the term sustainable has come to be synonymous with environmentally sound or friendly and green. Nowadays, we are all talking about green technologies, green products, and all. Right. That is where the green aspect is coming in. Right. So here, what is happening? The environmental component is taking precedence everywhere. It is our attention now because deterioration of our environment is driving the current worldwide focus on sustainable development. We say that yes, it is deteriorating day by day. So how to improve this one? Now, climate changes are happening, right? The most troubling for the long-term health of the planet and for the goal of sustainability are the climate changes resulting from the thinning of ozone layer. Understand this thinning of ozone layer. That's where the Rio Earth Summit has also taken place. How to reduce the pollutions and all, such that ozone layer is not depleted very much. That's where the progressive decline in biodiversity resulting from loss of habitat is happening. Right? So this is one thing that all over the world we are talking about how to reduce our pollution effects, to see that the ozone layer is not depleted day by day. And thereby, what is happening? It is environmental degradation is happening, right? When people are struggling to obtain the resources essential for life, food, water, shelter, etc., and it is inevitable that the basic economic struggle may take precedence over environmental sustainability, right? And then what is happening here is like America is telling India is producing a lot of pollution, right? Whereas India is saying no, you already spoiled it. Let me also do my part. Right? But I have to live, right? In order for my sustainability, for my living purpose, yes, at the moment I have this technology, I need to go only with this. Can you please transfer your technology? No, they are not ready to transfer the technology. So free. That's what India is already taking the lead of the rest of the countries. You please transfer if you have the technology, otherwise keep shut. Right? This is what is going on. This is the economic sustainability, what we are looking at. Then the other aspect is the construction materials. How are they driving this towards the sustainability? Right? If we are looking at the construction materials, right, is a very broad issue. The critical elements of environmental impact are utilization of resources, embodied energy, and the generation of waste materials. Embodied energy is we are constructing a building. What is the energy that it is taking? Nowadays, everywhere air conditioning. Now this air conditioning is by means it is an artificial energy that we are pumping inside, right? Green building principle says that try to get as much ventilation as possible. Now we are covering it everywhere and then trying to see that glass is also fully kept, and then we are coming up with the artificial lighting. So green building principle says let us try to derive as much ventilation as possible, try to use the artificial lighting as much less as possible, thereby we will be consuming less power, right? So that is where it is. And then, so these are the issues, the engineers that whenever they are constructing a building, nowadays we have so many technologies like drywall construction and the concrete wall construction, precast construction, so on. What are these different types of technologies which are going to be used there? Yeah, what is the energy that they are trying to derive? I will try to substantiate in the slides that are to come. So here, when we are looking at the construction materials, production of material, its construction, life cycle and demolition. Finally, the building also will be demolished, right? So the production of material, any material that you are thinking of, suppose it is cement, cement is also being manufactured, right? It consists of certain raw materials, we are manufacturing it. Thereafter, I am trying to use it in the construction. So in the construction again, cement, sand and aggregate, we are trying to use it in the concrete construction, right? And then what is its life cycle, right? This is the biggest problem that we always people keep asking me whenever I design the building, right? I say that the life of the building in my design brief report has 50 years. What? It's not going to look sustained for 100 years. But we say that, gentlemen, there is a maintenance factor. So if you add that, keep maintaining your building, 50 will go to 100. Otherwise, 50 will even come down also. So you need to maintain your building also at some regular intervals, right? The consultant have to talk to the client right in the beginning, saying that, are we looking at a 10-year maintenance period, or are we looking at a 20-year maintenance period, or is it 5 years? Based on this period, he will always look at what sort of materials he is going to be using in his building, right? So that is where the call is, and then try to move forward into that. So manufacture, when you are looking at the manufacture is an essential element in computing the environmental factor. How am I going to manufacture the material that is required for my construction, right? Are the raw materials renewable? Are they scarce? Are they important to the global environment? How much energy is required in the manufacture? How much waste is produced during the manufacture? What impact do these wastes have on the environment? These questions are very important, right? And when we talked about waste product and all, nowadays, previously, we were all thinking that fly ash is such a waste material. Nowadays, it is so much useful in the concrete and all. After some research and all, people are trying to use the fly ash to an extent of 30 to 50%. The other day, my cousin brother from my village was telling me, I am not able to get fly ash from Vijayawada because the government itself have taken up so much of construction. Nowadays, in construction of EWS housing, all these contractors are using the fly ash into their concrete mix. So there is the fly ash is not going to the rural villages. So they are struggling. So fly ash, whatever we thought it is a wastage, yeah, it is now wonderfully used in the concrete mixes where in the rural villages where they are trying to produce the fly ash bricks, they are getting a space now. So that's why we are renewing the product, right? On one hand, we have used the coal to produce the thermocoal, but whatever the waste that was coming in the form of fly ash, that is also being extensively used in the building, right? Now, this morning I went into the sites where they say that they are showing some cracks. And then some engineers are saying that's because of usage of fly ash, these cracks are coming, right? But then I asked, what is the extent of crack? The extent of crack is only about 3 to 5. I said, put a binding wire and see to what extent it goes. It goes only by 3 to 5 now. They said it is only a shrinkage crack to the draining of the water. The fine product being on that, it's not a real structural crack. Let's not get worried about it. But I told them, you should be very quick to start curing the element as fast as possible. As soon as it dries out, then the cracks won't appear. Right? We need to find out the solution. And so, how much waste is produced during the after? This waste is reusable. This waste is reusable. We have been producing the concrete, ready-mix concrete, which is coming to our site. But in the process, some concrete also goes waste, right? If I say I need 32 cubic meters, Yeah, the fellow will be sending not 32 exactly, maybe he will be sending 34 or 35. Where should I use this 3 cubic meters extra? Right? This fellow will simply take the truck and then dumps it away and then goes, then it is a wastage. Right? So we also need to find, but if there is a good intelligent project manager, he will try to take that and then use it for some other works of his grade slab concreting and all that. Right? But some wastage is there in concrete also. I've seen in Delhi, yeah, ILFX have put up a particular factory to collect all these wasted concrete from the big multi-story building constructions, and then saw that all this is collected and it comes to them. What they have spent is hardly about some 30 lakhs in setting up the factory. Now they are minting money to an extent of crores in breaking that particular concrete and segregating the aggregate from that particular one and then trying to reuse it. Right? So that's how the people are trying to reuse this material also. But the question is, when I am trying to transport that one, what is the extent of transportation that is going to get? Right? But they found a method whereby they can segregate the core segregate from the rest of the fine material and then try to use the rest of the material for the road and other purposes etched up into a structural concrete. Right? So it is also useful enough, people are using it to that. Right? So the construction process, it also involves some expenditure of energy and produce some waste. How much of each manufactured material is used? Can materials be used that have less environmental impact? Yeah, this is more important. Less environmental impact. Earlier we used to have these clay bricks. Yeah, nowadays the clay bricks are also born. We are trying to come up with AAC blocks, right? Autoclave aerated concrete blocks, right? So here they also use the aluminum powder and sand, and then it will they will put it in their container. It will form a foam, right? And it will become a cake, and then they will cut it and then use it. It has a wonderful thermal efficiency. The block thermal efficiency is 0.18 watt per square meter degree Kelvin. That's a fantastic. Thereby air conditioning loads will come down. So we found a beautiful material. So we have been telling that there is no need to use clay, where the people are trying to take the clayey soil from the agricultural fields. Our agricultural fields are getting dried up by taking this particular clay. So the construction industry has moved towards the AAC block. We already have about Nukan blocks and frame blocks in and around, and so many companies are there in manufacturing and supplying to the people. All the people are using. Right? Then the sustainability is lifetime repair and renovation. Right? Now that's where I said the maintenance aspect, repair and renovation. Yeah, the lifetime structure has a direct impact on sustainability. When the structure deteriorates, it must be destructed and rebuilt. The lifetime is directly controlled by the durability of the construction material. What is meant by the durability? Right? The IS 456-2000, the concrete code for design and concrete, it specifies from the durability aspect, right? The environmental conditions are given as mild, severe, extreme, like that, and then it gives you corresponding to these conditions what is the cover to be maintained. Cover to be maintained is specially given to see that, yeah, it will not have the corrosion to the reinforcement that we are providing inside the column or beam or a wall, right? So that is fundamentally the durability aspect, right? I will come to the 5 aspect a little later, right? And the adaptability of the design to repair and renovation. Whether it is an architect or structural engineer, both of them have to sit together and understand what sort of material they are trying to use, what is the lifetime of this particular product. Nowadays I am seeing architects have been using so many products which are coming in the market, and there are certain facade elements which are coming from Germany and other places where the facade elements are manufactured with the waste of paper, right? They are compressing the paper and adding some more elements and making a very thick element into the thin element like about 10 to 6 to 10 millimeter, and that is being used for facade. But then, what is the durability of this material? Is it 5 years or is it 8 years, 10 years, 12 years? A maximum of 10 years. I asked the fellow who has come from Germany, what is the durability? He says 10 years. So that means the client should be made aware of gentlemen, if we use this product, after 10 years this product is going to decay, you have got to replace this. Then he will take a call whether to go with this or try to go with a product which has a longer life. So durability has an aspect. Even when we provide glass also, the particular glazing will only last for 20 years, right? So we need to replace the glazing. So what sort of glazing we are going to provide? And the sealant that we are providing in between the glosses, yeah, that is also, the sealant also will last for 20 years. Yeah, you have to remove it and then put it. What about the gloss? So here the durable aspect, yeah, that we have to consider in providing the particular product and then advise the client also, this is the product I am doing, this will last for so many years, after so many years you need to replace and then repair it or renovate your building. So what happens after a certain point, the purpose served, destroy the building, right? Now we have a 2-story building, this Vijayawada has become a capital city. Now you see that all 2-story buildings or 3-story buildings over a period of time they will be demolished and apartments or big building, office buildings will be coming in, right? That is where we are saying that the purpose is served. The purpose is served and the owner is going towards its commerciality. I am going to get more money, no more residential building, he will change it, right? So purpose is served, then you are demolishing. Again, when you are demolishing, then what is the waste that you are generating? Is this material useful, right? What is the energy? Where are we transporting it? Is it outside the city or is it enough that we can put it at a nearby place, right? Then we look at sustainability and energy as an aspect. So during its life, the structure uses considerable energy. Energy used during the life cycle is a key element in computing its environmental impact, right? Nowadays, reviewing the durability aspect, we have advised the government of AP to go for this monolithic construction, which I shall give you some details about it. But then, this monolithic construction is a concrete wall, right? If it is a concrete wall, then the people keep asking me, what about the heat that it is going to generate? Does it require air conditioning, right? There are some of the aspects which we have to look into when we are going for a concrete walls and all. They are very strong, rigid, robust against any earthquake that is going to come. The building that we have suggested, they hardly deflect by half a millimeter for a 4-story building, right? But what we told the government, yeah, directly to the government official and right in front of the Chief Minister, I said, sir, let's not construct ghost houses. If whatever the housing board and other people are constructing are all ghost houses, because the quality of brick is poor, right? It does develop cracks and then it is attracting the moisture and people are leaving the houses even though you are giving free. So let's not do the same mistake. Let us do this monolithic construction concrete walls. People will stay forever and generations will be going to live in that buildings. So those building photos I will be showing it to you. So demolition, as we have seen it, the final stage of life cycle is demolition. How much of the structure can be reused? Predominantly we can use, if we are able to separate it out, the coal segregate from the cement and sand particle, yes, you can use it, and you can use other product into the roads also like that. And how much of the product, like whenever you are demolishing, I tell you, whenever we want to demolish, we call a demolition expert. Sometimes the fellow will come and look at it to demolish, especially in Hyderabad, 3-4 buildings we have done. That fellow will give you money reverse, right? I will demolish this and this is my money, because he is going to salvage the material like doors, windows and other things. He will also even pull the wire, whatever the electrical wire is there, right? And he will take the copper out of that, he will sell it. So he has his business, he will do that, right? So it is a reverse process, right? Whenever we can, because the owner is not going to use the same old doors and all. He is going with the new product which are coming out as aluminum doors or UPVC doors, which is that, not the old type wooden doors and all. So there is an advantage. To what extent we can salvage the material is a call that we have to look at. So at the end of its service life, a concrete structure must be demolished and disposed. The demolition process is done by brute force, depending on the size of the structure. It may involve controlled blasting and some type of hammer. Okay, this process is modest amounts of energy. It is sometimes recycled, most commonly used as a rock in a pavement base, as I told you, in the roads and all. Right. Now, waste generation, recycling. Yeah, waste includes unused concrete, what I said, and contaminated wash water, used formwork. Formwork may be wood, which must be disposed of in a landfill, right? But sometimes it is steel, which can be reused. It is concrete is sometimes recycled, right? And then the waste produced or demolished concrete structure include dust, powder, fragments of concrete. These are typically landfill sometimes. Yeah? We can call the guy, and then the guy says, "Sir, wait for 1 week. There is going to be a big excavated area. I'm going to dump it there." So he will try to use it, but you have to wait for time, and then the other guy comes and try to use it. Then we will look into concrete, steel, and other materials of construction. How we are going to about sustainability, the concrete material. What we are going to like. Concrete is safer. The building's core, whenever we design a high structure, usually it is a lift core, right? It's a big channel element. We'll take it as a wall, right? And then this has high moment of inertia compared to rest of the columns, which will contribute only about 5 to 10% of the stiffness. This will get about 90 to 95%. Thereby, it will resist all the lateral forces due to wind and earthquake. So thereby, the concrete element is pretty strong and pretty durable. It will not get cracks or anything else, right? And it has outstanding resistance to explosion and impact, right? It can also endure very high temperature from fire for a long time without loss of structural integrity. From fire also, it has a very fantastic resistance, right? 2 to 4 hours resistance depending upon the thickness of the element that you are going to provide. Even in your code, the code tells for 0.5 hour what should be your wall thickness, slab thickness, 1 hour, 1.5 hour, 2 hours. The code gives you the thickness of the element that you should provide, not only the cover. Then for columns and all, they describe about the cover. So it has no additional fireproofing treatment to meet stringent fire codes, right? And then concrete can resist winds of more than 200 miles per hour wind power. And ductility, yes, it can exhibit increased ductility, not like much more like the steel, but it does. We are providing from the ductility point of view. Your code IS 13920 covers extensively from ductility point of view at what intervals you have to provide your shear links and all. Right? And then steel. When you look at steel, right? Well, my friend Srini does wonderful steel structure. All airports are his. Yeah, I'm very much. He is very much passionate, and I like it. Whenever I go to Bangalore airport or Mumbai airport, I always keep my photo towards that. Right? Fantastic joints and all they have done it. But then when you look at it, WTC towers. When you are looking at it, it is a jet-fueled fuel pipes are to blame for the reduced structural integrity of the steel. Right? Concrete will not be falling that much, but here the fire that has come out of that is so much that it has engulfed, right? And then it has the steel by itself has only half an hour fire resistance. Afterwards, it will start melting. So the code calls for you need to give a fire protection material, right? It is in the form of intumescent paint, right? Or nowadays we got some cement-based products also. Or you have some plaster boards which can be put around, which can have 2 hours fire resistance or 4 hours fire resistance. But then sometimes these intumescent paint and fire boards are costlier than the base material itself. Okay, steel is wonderful material. It strength to weight ratio is fantastic compared to steel, compared to concrete. Concrete, if I say about 20 meters, I require a huge concrete beam, but steel it will be quite less. Right? So much of depth is not necessary because strength to weight ratio is fantastic. But again, you need to protect it from fire. You need to give sufficient protection from corrosion. Otherwise, if you are not doing that, from corrosion point of view, the steel which is manufactured from iron, it will go back to its original compound iron from steel property. So you need to protect it from corrosion as well as fire resistance. Right? And it is a wonderful material in terms of ductility. If you look at the Burj Dubai Tower, which is now renamed as Sheikh Khalifa Tower, the world tallest tower, right? The top 80 stories, 160 stories is concrete, top 80 stories is fully made up of steel. And because steel is so ductile, they made it to see that the steel can take that particular fatigue that is going to develop as the structure is going to deviate on the top by 1 meter daily this side and that side, right? So steel being ductile, it can take that much amount of ductility and movement and the fatigue that it is going to result out of that particular movement, right? So we'll look at the different types of technology. First off, we have covered a little bit on sustainability. I will now come to you the different types of technologies that are ongoing throughout the country, right? And then we look at what are the advantages and disadvantages, various aspects that are going on. One is the shear wall monolithic construction. Second is insulated wall pattern construction. Third is light gauge steel, precast prefabricated construction, and the last one is composite construction. This is the construction now. You can just go around and see in and around Vijayawada, Guntur, Amravati areas, and everywhere, right? See, initially it used to be called as the aluminium shuttering, Maiwan. Maiwan is one factory which is manufacturing this aluminium shuttering in Malaysia. So that is the name it has got. Like all Indians will say Xerox, because but it is basically a photocopier, where so much used to call it as a Xerox. So here also the people still call it as a Maiwan. Okay, but it is basically aluminium formwork. It's called as a monolithic construction, where the concrete will walls and slab will be poured. The concrete will be poured together, right, on the same day, and then all these shutters are 2 feet wide. Length can be 3 meters, or 4 meters, or 2.5, whatever the height you want, you will get it. But it is basically 600 wide. So one labor can just simply take the element and fix it there and connect the two elements, which is easier. Compared to plywood and steel, it is so light that one person can handle this and then keep fixing this particular one. And the beauty of aluminum shuttering is that, it can go on for generations. It will not get rust, it will not get corroded, it will go on for generation, and you have to use that provided we are handling the material carefully, not by throwing it and then the edges get knuckled and then keep maintaining them. If you do a constant maintenance, yes, it will go on for generation, other generations can also use it. There is no need to again refabricate and do the material. Right. Okay. I will very quickly finish. Right. So there are some advantages of faster construction, 5-day cycle construction. That's a beautiful advantage of it. Then see, this is how you can see this in Bangalore. We built it for Bangalore Development Authority. There is no need of any plastering. The concrete surface, you can directly do the painting. Right now in Amravati, they are constructing these particular. You can have a look at it. At very near to this place, K.A.Prasad, some of you might have gone there. Through government of AP, we have designed some buildings using different types of technologies, monolithic, and then we have also done some all the other technologies. You can go and look at them at K.A.Prasad, hardly about half an hour journey from this point. This is called the insulated wall panel construction. This is what we call as expanded polystyrene. It has a reinforcement on either side. Then the people will do the short treating. Like this, you can see the person here doing the short treating, 50 mm thick, and being this element inside, it will have the reduced heat inside the building, right? Thereby it is very energy efficient. From outside to inside, you can see a 4 degrees centigrade temperature difference even in the hot summer. That's the beauty of the element. So this building, you can also see it. We purposely left some buildings unfinished at K.A.Prasad. Any one of you can go and see. You can see this reinforcement over that, and polystyrene is also left. At that building, same building is finished when it looks like. You can have a look at it. Right? This is how some building. Light gauge steel construction. Again, this is not taking very popular method of construction for outside. For Jindal and Steel plant, Jindal Steel and Power Limited at Raigir, as well as at Orissa Angul, we designed and built a 4-story building. Yes, and my friend Srinidhi has also been actively involved in some 11-story building over there in the structural steel construction. And he used the previously built, see this particular one here. These particular ones to the building, he has used them as shear walls, external panels, and then designed the 11-story building. This is a beauty to the building. So different concepts, we can use it. So on top of an existing guest house, we just simply built this, where the same load bearing RCC wall is not possible. With this light gauge steel, this case quite easy to build it. Right? Composite construction nowadays is also happening, right, everywhere. The steel and concrete slabs, and steel is encased into the steel columns are encased into concrete, thereby corrosion protection and pipe protection has automatically happened here without the application of any paints and all, right? So you can see here some of the buildings. You can also see here where, as we said, demonstrative buildings, steel columns, steel buildings, and the metal decking. And you can also see some over the steel frame. We just simply put a hollow core slab. So it's also a composite construction, hollow core slab, which is a part of the precast construction. Now some Chinese have come and built their technology. It's totally the steel frame inside, and they use the lightweight polystyrene modules, the concrete wall, yeah, which will reduce the heat also. They use the same thing on the rooftop. They built about some 10 buildings over there. You can see that construction also. Precast is taking the shape wonderfully throughout India. We are going to hold one more conference here in Siddharth Engineering College on 19th to 21st. Right? You can also see some more examples of precast and composite construction to that. Here you can see a 3-story column, 2.5-story column are brought to the site at one go, and then they are just connected at this point. So this is the advantage of precast. At a time you can do that. And then slabs, precast slabs are 1.2 meter wide, hollow core. They can be put on the brick walls or on the columns wherever you want, and the floor slab is done in one day. Very simply into that. So many companies have already come into India, and they are coming day by day. Even in Vijayawada, now we are going to get about 4 factories where we have been motivating the guys to set up, and government is also thinking in terms of precast is the only mode to construct the building. Some of these buildings you can see brigade arches, basement to sleepless floors. They are built with totally in precast columns, beams, and then the wall panels. Yeah, this is how the building looks like. Multi-level car park terminal 1B in Mumbai, right? And then this is 1.1 lakh SFT. Yeah, this is one industrial building. They built it in about 7.5 months' time. That shows the speed that they are going to achieve into that. Yeah, precast columns, lifted and placed right into that, and then they will be doing the jointly connection with an institute, which is a monolithic rigid connection with a compound wall construction. This is a wonderful one for Infosys, which they built the external facade. Yeah, what we can see here, all those elements are being put into the shape over there. The architects has envisioned that air will be coming in, ventilation will be coming in automatically. It also acts as a facade, a beautiful concept. But the precast contractor have delivered that with the precision. Is a fantastic thing, right? So that's how the elements are. So many examples of precasting. Right? That's how the elements are stored and then kept in. Right? Some more pictures. Now if you can look at this 1,65,000 SFT precast delivered this in about 4.5 months time in Hyderabad. Hospital building is just built in 4 months time. Right? So we have this example where 2,02,000 SFT is just built in about 5 months. Here is again composite, steel columns, steel beams, and then hollow core slabs kept on that. So that demonstrates how the buildings are built in, yeah, at a faster pace. And today, what we are seeing is ready-made sheds and all. We are now going for ready-made buildings, right? So which is a possibility. Somebody wanted a canteen block, it is delivered in 38 days. Somebody wanted a school is delivered in 28 days within a month, right? We have designed a building in 15 days and then delivered the building in about 3 months' time in Bangalore for a school. It's a 3-story building, right? And slabs have gone from Hyderabad to Bangalore, right? So that we are able to deliver. So that is the speed. We can see that SCMC building is built in 30 days. So precast is going to be taking shapes. With precast, what is happening? You see that there is no congestion of any formwork and other things. Elements will come directly. No congestion. Fantastic way to look at the site. Here is the long T slab, double T slabs, what we call, right? And they can span up to 30 to 45 meters. You can see this wonderful space, column-free space, right? And then the shopping mall fellow will love it to place his furniture wherever he wants, his stacked material and all. So this is another technology which is coming. The last slide, which I am going to cover, here we will be talking about sustainability.